Good morning, students. Now in this lecture we are going to continue with the examples based on composite functions, differentiation of composite functions. So let me consider the function given by y is equals to sine of x square plus 5. This is the first example. This happens to be a composite function. Now the derivative of this composite function, as I told you in the last lecture, is found out by chain rule differentiation. So, differentiating with respect to x, what do we get? dy by dx will be equal to d by dx of sine of x square plus 5. It is equals to sine of x square plus 5. So, sine x is the outer function and the inner function is x square plus 5. Right? Sine x happens to be the outer function, the inner function happens to be x square plus 5. So, this will be dy by dx will be equal to derivative of the outer function, that is sine x is cos x. So this will be cos of x square plus 5 into derivative of the inner function. The inner function is x square plus 5. So it is x square plus 5. So this will be equal to, this I am writing it as dy by dx. So this cos of x square plus 5 I will be keeping it as it is. Now, what is derivative of x square plus 5? It is 2x. So, into 2x. So, derivative of sine of x square plus 5 is 2x into cos of x square plus 5. This is one of the examples. Right? So, the next example you will be seeing is y is equals to secant, okay, so it is cos of x cube into sine square of x raised to 5. So here it is first I have to apply the product rule differentiation and then the chain rule differentiation. In this example, it is the product of two functions which are both cos of x cube and sine square of x raised to 5. In cos of x cube, remember, it is just function of a function. But in sine square of x raised to 5, it is the composite function of three functions. Composite of three functions here. First, outermost function is x square, inner function is sine x, innermost function here is x raised to 5. I repeat this, here it is the composite of two functions, but in the second term, it is the composite of three functions. It happens to be the composite of three functions. So, first step is differentiating with respect to x. First one is differentiating with respect to x. What do you get? dy by dx will be equal to dy by dx is equals to d by dx of cos of x cube into sine square of x raised to 5. So here I have to apply u into v method. So this will be equal to dy by dx will be equal to first function, keep it as it is, that is the first function is cos of x cube into derivative of sine square of x raised to 5 plus second function, keep it as it is, that is sine square of x raised to 5 into derivative of the first function, that is cos of x cube. So this will be cos of x cube, which is here I have to apply the chain rule differentiation. This first function, there is no derivative symbol, so this function I will be keeping it as it is. Here, what is derivative of x square? Derivative of x square is 2x. So this will be equal to, I will be writing it here, 2 into sine of x raised to 5 into derivative of sine into derivative of sine of x raised to 5, right? Plus sine square of x raised to 5 into, what is derivative of cos x? It is minus sin x. So it will be minus sine of x cube into derivative of x cube. So this will be equal to 2 into cos of x cube into sine of x raised to 5. What is derivative of sine? It is cos. So cos of x raised to 5 into derivative of x raised to 5. Here also it is the composite of two functions. Here the outer function is sine and the inner function is x raised to 5 minus derivative of x cube only. So it is 3x square. So it is 3x square into sine square of x raised to 5 into sine of x cube. So this will be equal to, now what is derivative of x raised to 5? It is 5 into x raised to 4. 5 into 2 is 10. So it is 10 into x raised to 4 into cos of x cube into sine of x raised to 5 into cos of x raised to 5 minus 3x square into sine square of x raised to 5 into sine of x cube. So this is how you find the differentiation. Note the steps now. I will repeat this problem once again. Very important steps that you need to know. First function, which is cos of x cube, it is only function of a function. Second function, which is sine square of x raised to 5, it is function of a function of a function. It is the composite of three functions. Here, while we are finding the derivative, here outermost function, first derivative you are going to find the outermost function, then the derivative of the innermost function, then the derivative of the innermost function. In this way, here it is only the function of a function. So first the outermost function and then the innermost function. Outermost function and then the innermost function. This you have to make a note of this. Right? So, the next example that we will be seeing now. The next example is y is equals to 2 times root of sine of x square. Y is equals to 2 times root of sine of x square. Here, differentiating with respect to x. Differentiating with respect to x. What do you get? dy by dx will be equal to d by dx of 2 into root of sine of x square. 2 into root of sine of x square. So, dy by dx will be equal to 2 is constant as you already know. So, it will be 2 into derivative. Here it is function of a function of a function. The outermost function here is root x. The outermost function here is root x. And you know that the derivative of root x is 1 divided by 2 root x. So it is 1 divided by 2 into root of sine of x square into, according to the chain rule, it will be derivative of sine of x square. Here 2 and 2 will get cancelled. Here 2 and 2 will get cancelled. So this will be dy by dx will be equal to, what is derivative of sin x? It is cos x. So it will be cos of x square into derivative of x square divided by root of sine of x square, and derivative of x square here is 2x. So this will be 2x into cos of x square divided by root of sine of x square. So this happens to be the answer. So as an exercise, try this. Y is equals to secant of tan of root x. Right? So in the next class, I will start with this example and implicit function.